Okay, hello everyone. Thank you for coming to the session. Multi-tenant data pipeline orchestration. First, thank you to all our sponsors. Without them, this conference wouldn't be possible. Please. Just a high-level overview. Today, I'll talk about data pipelines, extreme challenges in data pipelines, which are multi-tenant. Complex orchestration scenarios, and how can we manage all of it, how can we keep it all together, and in the end we'll have time for questions, but feel free to stop me if you have very important questions in the middle. About me, I've been working on data pipelines throughout my career in various companies, in various complexities, usually in various domains. It was about mixing data from different sources and bringing them all into one single usable data set. And I'll talk about the challenges in these kind of pipelines. Right now I'm working as a consultant in this field. So the goals for this session, what I want you to take from it is what I want to give you is to share some of my experiences, some challenges I went through that I had while building these pipelines, to give you some insights as to what you need to consider, what you need to think of when you come to design a new data pipeline, to ingest new sources, and in the end we'll go over a few take-home tips that I hope will help you in your work. Before I begin, for how many of you does this screen look familiar? We'll get back. So in the beginning, in all our data pipelines, it always starts from a simple scenario. Here we have a toy example. We have a chips factory, and we're monitoring the production with photos or video. Oh, sorry. Now you can hear me. We're monitoring the production with photos, and then we ingest them through a data pipeline, which goes through some processing. And in the end, it reaches a dashboard and perhaps machine learning. Now, in the data pipeline, typically, however you design it in whichever system, consists of the initial part where you take the raw data and ingest it as is, the middle part where you do the processing logic, which may be complex business logic, that goes through all the sources, and eventually you provide some aggregated product. So today we'll focus about the challenges of the middle part of the data processing, assuming that we have different sources that ingest into some data storage, and the outputs of our data pipelines are integrated eventually into the deliverable. So a simple multi-tenant data pipeline is where you take multiple sources. These are tenants. So going back to my example, if my tenant is a factory, I ingest all the data from all the factories and process them in the same way, in the same pipeline. And this is the simple way. And the unsustainable way is when I try to accommodate the differences between them by building a separate, distinct data pipeline for each tenant or for each group of tenants. Now let's see why this doesn't scale. So first, we'll talk about the dimensions of scalability. This is from a lecture about partitions from Dexter. This is one of the leading orchestration frameworks, but I'll simplify it here. We will have our data volume growing as we get more data, more tenants, more domains, and the naive approach is to process the data from all the sources, all the tenants together, and then our cost and the processing time increases together with the volume. And what we want to have is that as our data volume grows, we still have about the same cost and about the same runtime. So basically decouple the growing volume from the resource consumption. Whichever resource it is, we're not going into details here. The first basic way to model handle this problem when we have ongoing ingestion of data is to model it as incremental data. So we ingest data, for example, per date, and we also store it per date or in whichever time resolution is relevant in your project. But assuming that data from different times is independent, and then we can ingest it separately and store it separately and process it independently. This doesn't apply to all use cases, but to many use cases it does help. And also we assume here that the data from different tenants is independent, and we can process it separately per tenant in parallel and independently. This gives us scale in the many tenants, but we need to consider two main distributions of tenants over time. So one is when we have the case, for example, we have research labs that provide us data over time, and with ongoing time we have more data from more tenants, but each tenant provides data for a limited period. So overall, during each time we have a rather constrained amount of tenants. And on the other hand, the other use case is when we have both data and tenants or data sources growing over time. This is the case on the right. And when we come to this storage, we want to consider the hierarchy between these two dimensions, whether we first start with tenant and then store the time dimension, or start from time and then go with the tenant dimension. This is a simpler decision in the beginning, but it may have an important effect downstream as our data pipeline gets more and more complicated. And then when we designed our pipeline to scale in both of these dimensions, in tenants and in dates, then we can execute this one pipeline and give it the time and the tenant as parameters and run it independently for all tenants and for all dates in this case. But that was just for linear scalability in the dimensions that we expect, that we know to prepare for. This is also not a trivial task technically, but this is a simple design consideration. Now we'll talk about dimensions of flexibility. How do we adapt our data pipeline to handle more unforeseen challenges? Back to our factory example. Here we have the factory, back to one factory, and we have a rather standard data pipeline. This is obviously just an example, but it's pretty representative. And even in this factory, we have several different products, and we need to process these products differently at some stages of the pipeline, but similarly or the same in other parts. The most compelling, tempting way at first, when this is the only complexity that we observe, is to split the data pipeline itself. And when we do that, we actually end up logically with a few data pipelines separately that start drifting and gaining technical depth, and it's more complicated to maintain. If we did that, we separated into a few data pipelines, then what happens when our complexity increases further? For example, here, we had different products, and then we're asked to add modalities. So we measured with just photos or video, and now we're asked to measure also sound and temperature and so on the same products in the same factories. And each time we'll have more and more dimensions by which the pipeline, the data gets more complicated, and we want to make sure that we're able to scale with the increasing complexities. And still, these are the complexities that are coming explicitly. Many times we'll have surprises from the data itself, as we start ingesting and processing the data, it's different among tenants. So here are some differences which I stumbled upon when dealing with multi-tenant data pipelines. We have equipment from different vendors, different software versions, different schemas, different working protocols, different regulations. I'm pretty sure that you also had some similar challenges in your data pipeline that you couldn't know when you started working, or even with your first tenants, and then discovered them as you went along. So what do we do now when we need to handle all these challenges? Let's talk about how we design our pipeline so it's successful, so it can be ready for upcoming challenges of this sort. First of all, my recommendation is to have a single data pipeline which is parameterized, and then we can even add variability to the parameters and keep the structure the same or changing very rarely. When I'm talking about the structure, this is in your orchestration system, and the differences in the code itself for handling different cases should be handled in the code logic of these steps and not branching out in the pipeline. Second, although we talked about many dimensions by which our pipeline can get more and more complicated, we should still remember that this is not a combinatorial complexity, because not all the variabilities actually exist in practice. We should be ready for all these dimensions, but not necessarily expect that the total amount will explode. Third, as I mentioned, it's very important to plan our storage to accommodate the data that is incoming. And yes, you can take pictures, and I'll even show that here I added another dimension of complexity that, as you can see, the depth of variability is not necessarily the same in different modalities. So if we have different products and then different modalities, and maybe in one modality we immediately have, sorry, this is a mistake. The product. This is the product. And in some modalities, maybe we have some divisions. So even the depth may be different between the modalities. And we need to take this into account when designing the hierarchy of how we store, and then how we process the data in different stages. And what all of this gives us is the flexibility to manage each slice. A slice here is the combination of all these parameters. We can process each slice independently. So if we need to fix something, rerun something, we'll talk about it in a minute. Then we can do it per slice. If we have a new modality added, we can just redo it on a specific slice and keep the others intact. So let's talk about intentional orchestration. How do we manage the orchestration of this segmented pipeline? First, we want to control every slice, and these are things that we want to do in our data pipeline in the slice level. So obviously we want to be able to run our entire data pipeline, but we also want more granular control. We want to be able to start each slice, to monitor the status, whether it was successful, if it's still running, to inspect the logs and metrics, to trigger execution based on some prerequisites, and to backfill if we fixed our data or code or both. These are a few common data orchestration frameworks. My goal isn't to give the session about the frameworks themselves, but just to illustrate that when we understand which functionality we're expecting from the framework, for example here, to execute the pipeline on a specific slice, the UI and API in these frameworks may look very different, but when we know what we want from it, then we can go look for it rather than the other way around when we're starting from the possibilities of the framework. This is how we trigger slice execution. These are the common frameworks: Apache Airflow, Dexter, Prefect, and there are many others. Also, how we monitor slice execution. Some frameworks give us an overview of all the slices, or a hierarchy, or timeline. But what we want eventually, this is what I showed in the beginning, the status of dates and slices and steps, and some hierarchy that we applied initially. For example, in Airflow, there's a more complicated UI which shows the status by the execution dates and the tasks themselves and their dependencies, their structure. In Dexter, and also right in the recently released, just a few days ago, Airflow 3, there's a different view by assets. So we're looking not on how our data pipeline ran or which steps were executed, but on which data slices are ready or processing that were used to generate these assets. And now let's talk a little bit more about automations, the steps that we want to be able to run based on some conditions, not just manual. We have a few automation triggers. First, the most basic one, I'm sure you're all familiar with, is running by schedule. So you want to run in a certain time. We want to run when a new input arrives, when a dependency, maybe another data pipeline finished, and then we want to trigger our pipeline. A threshold was crossed in the database or in some system, and maybe some size went over a limit. And in some cases, we want to allow an external trigger. Now, these are many possibilities. I'm sure you used some. Maybe some cases are more relevant than others. But even these, as simple as they seem, have challenges in the multi-tenant environment. these are all from personal experience. So for example, if you need to run a nightly job in a multi-tenant pipeline, you need to run the pipeline at midnight, but you have different tenants, and for each one, midnight is in a different time zone. So you need to orchestrate it by tenant. Input may mean a file arriving at the bucket, or maybe you're polling some API endpoint or some website. It also can be different by tenant. Each tenant says, I will give you the files through some different interface. A threshold also may be configured differently by tenant. For example, the batch size can be different. The event, we don't want just anyone to trigger our data pipeline execution, so it can be maybe a different endpoint. And also when we want to run our pipeline manually, there are different considerations. So let's talk about this. When we want to rerun our pipeline, for example, if some step failed or we need to recalculate it, then this is a backfill. And we have backfills in a few different scenarios. One scenario is when our step in the pipeline failed, and then we want to rerun it. Usually this is done automatically by the framework, but sometimes there is some external condition, maybe disk was full and we want to fix it or to empty it and then to rerun it, but just rerun the one step that had a problem. Sometime our pipeline will look as if some steps were successful, but actually the downstream will have empty outputs. And this is because we didn't handle the case where earlier steps gave us empty input. This is the case where upstream, maybe our upstream was delayed. We expected it to come at a certain time, but it didn't arrive and it gave us empty input. And then we need to figure out that which was the earliest step that generated the empty files and rerun from there. And the last case is when a step in our pipeline generated a corrupt output, but it wasn't discovered immediately in the subsequent step, but only sometime later, can be sometime in our pipeline or even externally. So let's see these cases. The first scenario that we need to handle is that we had an IO error, maybe we failed while writing the output, and then we just need to clear up the artifacts and invalidate the step and rerun it clearly, and that will fix the problem. Some scenario which is a little more complicated, but we should be aware of, is that it looks okay, but it failed some validation perhaps later. Maybe we wrote a file, the file was written and was read by subsequent steps, but we did a partial schema. So we missed some fields, and then it falls only on a very late stage when this field is required. And the last case, when we have a downstream corrupt files is when our business logic is incorrect. And this case is sometimes discovered a lot of time long after our pipeline finished, because our files, our outputs were written correctly. They passed all the validations. They generated all the outputs. They were consumed by whoever gets the outputs from our pipeline. But then, sometimes later, maybe someone redid this calculation, and it turned out that we miscalculated, and we can't just say, oh, sorry, I'll rerun the pipeline as is, and I'll give you a new result. We need to audit what was the downstream effect, maybe on the business. We also can't just throw away the wrong outputs like we did earlier with the corrupt file. We need to save it aside and very carefully to rerun the pipeline, and obviously downstream consumers to notify them and rerun their calculations and audit the impact. Summary. A few tips from this was not about a specific library or a specific framework. These are general design principles, which I hope you'll remember when designing your next pipeline. First of all, decouple. When you're designing, decouple the processing, the storage, and the orchestration. Don't start from whatever the possibilities are in the orchestration framework or the structure of the data that you encounter in the first tenant, but blend them separately. Design the storage hierarchy. This looks simple, but it's very important. Try to design the storage hierarchy so it accommodates growing in various complexity dimensions. Expect the complexity to grow and prepare for it. Not just so you can process parts in parallel, but that you can really handle upcoming challenges. I'll mention this again because I mentioned it in the beginning. Handle each data slice separately so you can monitor and fix it and understand the implications. For example, if you have a bug that causes slowdown in only a certain slice, and you run a few slices together, you didn't split them enough, then you'll experience a minor slowdown, which may even fall below the threshold. But actually, it's a major slowdown on a very specific part. Or when you have a failure that you don't handle records or inputs of a certain kind, and then maybe you usually have different data coming from different customers, different tenants, and you accept a certain failure rate. So don't hide the 100% failure rate in a very small subset of the data as a 5% failure rate in the data, the input processed together. And the last thing, decide knowingly that you want to monitor the slices, their execution, their status, their logs, in all the levels, from the tenant level all the way to the slice level, and don't let the framework, orchestration framework, limitations to hold you back. In some use cases, you may even need to connect to the database of the framework to get the run status and build your own dashboard. but it's worth it for visibility. And that's it. Thank you very much.